I love that Wonderfest can bring insightful Bay Area scientists to the library. Sometimes, like today, those researchers are Wonderfest science envoys. This means that they are young researchers who are particularly dedicated to science outreach. Wonderfest helps these science envoys to perfect their science communication skills. Today's speaker is UC Berkeley arachnologist Trinity Walls. She's an advanced PhD candidate studying jumping spiders with Cal professor Damien Ilias. Trinity earned her bachelor's degree in biology at Washington University in St. Louis and her master's degree in biological sciences at the University of Cincinnati. I said that Trinity studies spiders that jump. As scary as that sounds, at least to me, Trinity prefers to say that her spiders dance, and they do much more. Please welcome UC Berkeley spider lover and Wonderfest Science Envoy, Trinity Walls.
Thank you, Tucker, so much for that introduction, and to the SF Public Library for having me. Let me share my screen. I have some slides to show you guys. I'm really excited to be here. Let's see. Get this going. And then, okay. Okay, I think we are in business. Can everybody see my slides? Is everybody good to go? Okay, wonderful. All right, so once again, hello everyone. Thank you so much for having me. This is going to be a pretty lighthearted talk. I'll tell you a bit about my journey into spider science and kind of how I got to where I am today. If you have questions, please write them down. I'm happy to take questions at the end, and I don't want you to forget them. That being said, I do love audience participation and will ask for it occasionally. Actually, I'm going to ask for it right now. So thanks in advance. If you can, please either use your raise your hand button or just raise your hand and tell me how many people are either actively afraid of or have immediate family members who are afraid of spiders. Okay, definitely got some people in there. Lovely, awesome. Okay, so fair enough. Well, hopefully after this talk, you'll find spiders a little bit more interesting and maybe a little less despicable. So once again, my name is Trinity Walls. I am a graduate student at UC Berkeley, and I love spiders. But the question a lot of people ask me is why? How did I get here? Why do you like spiders? And in a nutshell, I've been into spiders since I was very young. I was always kind of romping around, looking at spiders, watching them build their webs, hunt for food, living their little spider lives. But people were always telling me, "Oh, they're dangerous. They're bad. They're not a good thing. Stay away from them." People really hate spiders. In fact, some scientists in 2019 asked about 1,800 people to rate 25 different types of animals according to how much fear and disgust a picture of each animal invoked. And the spider got equally high rankings of disgust and fear. So very high. They're one of the ones that people dislike the most. They they were also deemed the scariest and grossest. So right up there with like tapeworms and cockroaches and things like that, which I found very interesting. So I think this graph is a good summary of people's perceptions of spiders. So if this is people's general perceptions of spiders, this picture on the left, harbingers of Halloween and terror, they make people very uneasy. How did I end up with this image on the right as my own perception? This large-eyed, very distinguished little gentleman over here, and yes, that is a male spider, um, who is just adorable. I just think just so charming. So I wanted to know what causes this uneasiness that people seem to feel in relation to spiders. So I decided to just ask people. What do you think of? And I'm going to ask you guys as well. When you think of a spider, what is the first thing that you think of? I'm going to give you like 15 seconds to think about this. If you have access to the chat, this is the time that I would look in the chat right now. So I'm going to give you 15 seconds, and at the end, I'm going to say 3, 2, 1. I want you to all put your first word into the chat at the same time. Okay? Can you do that for me? Thank you. I'll give you 15 seconds. Oh, it's happening now. I can see it on this side. Okay. Okay. If you haven't done it yet, do it right now. Go ahead. Do it right now. Okay. All right. Okay. All right. And yes, the eyelashes are real. I will come back to that. Okay. Excellent. I also just realized there's a second second me online. I think that is my family. So if it seems like I'm also typing in the chat, it's not me. It looks like my family has tuned in. So hello to them. um, okay, so yeah, so we're seeing a lot of their uh, scary. They're very hairy. They have too many legs. Things of that nature. A large variety in there. Mostly negative things, but a lot of variety. So thanks for participating. Many of these I have heard before. In fact, when I ask people this, people usually tell me, oops, it's frozen for a second. Yeah, people usually tell me spiders have too many legs, too many eyes, they're hairy, they're fast, they're mean. Okay, so I tend to ask people, they're too leggy. What is the appropriate number of legs for an animal? And people say 4 or less. And I say, oh, okay, that seems like an arbitrary number, but okay, got it. At least you have you've got a, yeah, they say they have too many eyes. I say, have you ever seen a spider's eyes? And they say, well, no, but they have too many. Okay, sure. And they say they're really hairy. Well, I say, so are dogs, cats, and a whole lot of people on this earth. So I'm really confused as to as to what the problem is. But okay, so we've got some characteristics that people have described. And I make these little quips about these characteristics, but many of these qualities played a large role in our current scientific endeavors and have really influenced why I became so fascinated with spiders. So let's talk about some of these characteristics. I could honestly talk for an hour on each of these individual things, but let's take a small snippet of time to dig into each one just a tad. Let's start with hairy. So I actually got super interested in the hairiness of spiders as a teen when I got my very first tarantula, which is depicted here. This is Anastasia. I've been asking for a tarantula for years. This was especially, honestly, very hard on my mother. I mean, you can imagine as a parent, oh, hi, child, what do you want for your birthday? Hello, mother. My heart's desire is your nightmares in living form, please and thank you. So shout out to her for being a trooper. But yes, after it took quite a while, but eventually my dad did finally bring a tarantula home for me, Anastasia. We were very inexperienced at the time. And so my dad was trying to transfer her into a new container. And in the process, he accidentally poured a bunch of dirt on her. Now, I don't blame Anastasia for being displeased by this. You know, a random human has now moved you into a new home, dumped a bunch of dirt on you, and then is now subsequently trying to brush off the dirt with a paintbrush. I'd be a bit flustered too. But she didn't try to bite him. If anything, she tried to run away. And at the same time, she was rubbing her legs against her abdomen, her butt, that back portion of her. So I'm wondering, what is she doing? Why is she doing that? So I had to look into it. Turns out some spiders actually use these hairs for defense. So many North and South American tarantulas actually have what are called urticating hairs. So kind of like these little barbed hairs. And they'll kind of throw them at people or throw them at predators as they try to make their escape. So this is what this looks like. The hairs are designed to stick to their targets and cause irritation, but ultimately it won't last very long and isn't really dangerous. It's just uncomfortable. So they don't really want to bite you. Producing venom is very expensive for them. It's a resource. They don't want to use it if they don't have to. So biting is often a last defense. And even the phrase throwing hairs is a bit extreme. It's more like dusting off an itchy cloud and then running away like a smokescreen. It's certainly not comfortable. You don't want them in your eyes, but they aren't automatically coming towards you with their fangs bared. Okay, so that was already super interesting to me, but I wanted to know more. What else can these these hairs do? Well, turns out many of these hairs are actually used for sensing. Spiders don't have ears, taste buds, and a nose like we do, but they can still use their five senses. We'll talk about their eyes later, but kind of like how we have hairs in our ears that help us hear, they have designated hairs and slits in their legs that are one for touch, taste, and odors. They're sensitive to those senses, and as well as they have hairs that are specifically designed to detect different types of vibrations in the air and on the ground. You could call them their hearing hairs. So they have hairs for all of these different things. And speaking of sensing vibrations, how many people have heard this myth before? We eat 6 to 8 spiders in our sleep. How many people have heard that? Some people, a few people? Yeah. Well, I grew up on this myth. I was definitely taught this as a child by my teachers. They would always tell me, "Oh, you eat 6 to 8 spiders in your sleep every year." So I used to believe this. And as I learned more about how spiders operate, how they sense the world around them, I realized this didn't actually make sense. Spiders, again, have essentially hairs, ears, whatever you want to call them, on their feet. They function to detect vibrations. So if spiders were to intentionally run into our open, sleeping, snoring mouths at night, it'd be like running towards an earthquake or a cave with a loud predator inside. I'm not saying it's never happened ever, but it's fairly unlikely. Okay, so already some really cool stuff. Something else I learned, some spiders have hairs on their feet called scapula, and also these claw tufts that you can see in this depiction, this diagram here, that actually give them a lot of adhesion and clinging power. You ever wonder why spiders seem to be able to run up your walls or be on your ceiling? It's actually because these hairs are super dense and actually act to increase the surface area that they can actually stick to. So they're like little sticky pads that they can use to walk along your walls and your ceiling. Lastly, and one of my favorite things about spiders is they're essentially waterproof, kind of. The hairs are actually hydrophobic or water resistant. A lot of these hairs are. So they prevent water from entering the spider's lungs or other air holes. At the same time, these hairs can create surface tension and allow some spiders to actually walk on water, or spiders can actually, some of them can be submerged in water and still pop out just fine because these hairs will protect their lungs from getting water in them. So this is a fishing spider in this particular picture, one of my favorite types of spiders, and it can sit on water and hunt that way. But we have even more extreme examples, including the diving bell spider, which scientists find fascinating because this is the only spider we know of that lives entirely underwater. So you can kind of see that it has this casing around its abdomen. That's actually an air bubble. And it is it's all of its hairs and lungs and everything are protected. It's able to breathe that way. And then it forms or creates what we call a bell. So this water bubble that it actually lives inside in the water. So very, very cool. Okay, so we've talked a little bit about spiders being hairy. What about all these legs that spiders have? What about those? So most of you probably know that spiders have 8 legs. Well, throughout my childhood, I remember seeing spiders that did not have 8 legs. Sometimes they had 7, 6, 5, even 3 sometimes. What happened? Why do these spiders have fewer legs? Can they survive that way? How does this work? So I decided to look into it. And I learned a lot of really interesting things. First, I wanted to learn a little bit about the anatomy. And so I learned that, again, legs are where all those hairs that I talked about are located. And these legs play a large role in movement and sensing, of course. But these legs also have a lot of different joints and segments. And these segments and joints have different functions. For example, for some spiders, their back legs have a comb like structure on the back of their leg that helps them pull out silk from areas near their spinnerets. And so it's actually useful for them to actually make their webs and do what they need to do. So their legs are pretty complex. But back to what I was saying earlier, one of the things I found that's most fascinating is that, yes, sometimes spiders do lose their legs when molting, which we'll talk about. I don't know if people know what molting is, but it's really interesting. Or they can lose their legs when molting or when they encounter a predator. But what's also super cool is that not only can they lose their legs, they can actually grow them back. So if you ever see spiders that have a transparent leg that seems to be smaller, a little bit stumpier than the other ones, they probably lost it at some point and regrew it. Um, this only happens before they reach adulthood. So once they become adults, they can't regrow their legs generally. But as long as they're not adults yet, they can regrow their legs, and the legs will get better and more formed with each subsequent molt. So, how many people have heard of molting before? How many people know what that is when I say that? Yes. Okay. Some people. Good, good. Some people. Okay. How many people have heard of a snake shedding? How many people have heard of that? People know what that is. Okay. More people. Wonderful. So people know that snakes shed. Spiders do something kind of similar. They molt, so they shed their skin, but what they do is a lot more in depth. So they actually shed a whole lot more of their body. So to give you an example of what this looks like, yes, I have some show and tell because I love these kinds of things. So when you think of a snake shed, you might think of something like this. So you can kind of see it. You can see, you have to focus on my screen for a second, not the shared content, but you can see that the snakes shed their scales. So this is like the outer layer of a snake. It's see-through. You can totally see how a snake would slither right out of this. So that's a snake shed. Like I said, spiders go a little more in depth. So I have, some of you might have noticed, I have a bunch of terrariums behind me that contain tarantulas. And when they shed their whole body. Let's see if you guys can see this. Can you guys see this? This is a tarantula molt. A lot of people, especially when you get close to it, if I didn't tell you this was not a live spider, a lot of people would think this is a live spider because the spider looks just like this. They shed their fangs, they pull their legs out, they shed everything. So a lot more in depth. And you can imagine when they do this, because they're regrowing a lot of things, they can actually regrow their legs in the process. Okay, hopefully you could see that pretty well. So yeah, they can regrow their limbs. Very interesting. Okay. So in addition to the things that we already mentioned, a lot of people ask, well, how do these legs function? How do the spiders move? They actually move using a hydraulic pressure system. So most spiders don't have extensor muscles in their legs. They don't have muscles to extend their legs, but they do have muscles to flex them. So spiders function using a hydraulic pressure system where their hearts essentially pump fluid into their legs, and the resulting pressure is what causes these legs to extend, which is interesting in itself. But I just want to put a side note right here. We often say that spiders are very creepy, but in some ways, I sincerely think we as humans are kind of the weird ones, the creepy ones, because recently scientists have realized that we can actually access this hydraulic pressure system in dead spiders. And so it's very interesting. But basically, scientists have figured out a way to access this pressure system and make dead spiders into grippers. Essentially, they use these spiders to grip other objects. So it essentially looks like this. they can access the pressure system, open the spider's legs, force the fluid through it, and then use it to grab other stuff. In this case, dead spiders, but they're looking to see how this could be applicable for other applications. Super cool, but a little bit weird. I do think we might be the weird ones in this case. Okay, moving on. So I also want to talk a little bit about biomechanics. So some spiders also have really unique movements and jumping mechanisms compared to other animals. So studying their leg movements allows us to better understand different types of animal movement. And this information is really important, not only for understanding animal movement patterns, but also engineers are using this information to improve the capabilities of modern robots. A former member of my lab, Aaron Brandt, the lab that I work in right now, Aaron Brandt, studied how jumping spiders jump and found that the spiders actually lift their first two pairs of legs before jumping. It's like in preparation to jump. They kind of stretch them out ahead of them. And they actually jump with their third pair of legs and assisted by their fourth pair of legs. So it actually looks a little different than we think, which is just really interesting. It's a little different than how some other animals jump. Lastly, I can't neglect to mention spider feet. Spiders use their feet for different types of behaviors. So their feet are often shaped to facilitate those behaviors. Most spider feet fit into two different categories. You have your three-clawed spiders, which have this third claw in the middle. And you often see this with orb weaving spiders and other spiders that spin webs because they use this claw to actually pull out silk and place it in different areas. So you'll often see this with, like I said, orb weaving spiders, web building spiders. And then you have two clawed spiders, kind of like the ones I mentioned before, that have these claw tufts and scopula, these really dense hairs on the bottom of their feet, and they're able to use these to stick to surfaces. So you often see this in spiders that run along the ground or don't build webs. And one of the things that I find is so interesting about that, I just showed you a molt of a pink toe tarantula, and people often think of the spider feet as really, really creepy. But if you zoom in really closely, they actually look like this. They're like these cute little spider toe bean looking things. This is a spider foot. That's what you're looking at when you're thinking of, oh, it's so creepy looking. That's that's actually what's there. Okay, so we've learned a bit about the functions of spider hairs and legs. Let's move on to spider eyes. Let's return to this little guy. So you can all see the spider's large, prominent eye structure. People often tell me, oh, I'd like spiders if they looked like that. You made that up. Except, no, I didn't. This is a male jumping spider found in Zimbabwe, Republic of the Congo, some other areas. They unfortunately are not here in the US, but they are really, really cool. Yes, his eyes are that big. And yes, he essentially has natural mascara that some of us probably envy a great deal. He also does have 8 eyes, but they aren't all readily visible. Those front 4 eyes are the ones that we would see if we were to see him. So this is all really cool, but I got interested in spider eyes long before I learned about this little guy. When I was younger, especially as a teenager, I would go outside, especially at night, and look for night spiders, nocturnal spiders. So I would walk around with a flashlight. And one day I was holding up the flashlight close to my head so I could see better. And I started noticing all these little like flickering lights. It seemed like flickering lights on the ground. People used to tell me, oh, those are dew droplets. That's just the dew that's going to form in the morning. That's just already forming. That's what that is. And one day I thought, why do I always wait to look at dew in the morning? I'm going to look at it at night while it's forming. I'm going to go look at it right now. So I approached one of these lovely little dew droplets and was shocked to find a spider staring back at me that was just as shocked as I was because it was not expecting me to approach it. So all these little dew droplets I was seeing was actually the reflection of my light in many spiders' eyes, in particular wolf spider eyes. Okay, now I got it. Now I'm into it. I'm hooked. I've got to learn more about spider eyes. So I've been kind of delving into that. And I've learned 3 really interesting things that I'm going to share with you today. One, many spiders have different arrangements or different eye arrangements, and you can often use the eye arrangements of different spiders to identify different spider families. This is a small sampling of spider families that I've shown you here on the right. Lots of spiders have, again, different eye arrangements and different numbers of eyes. Some cave spiders only have, actually, they have no eyes because they don't need them. There's 0 light in the cave, so they only use the hairs that they use for sensing. But yes, spiders can have anywhere from 0 to 8 eyes. And those different eye arrangements facilitate the different spiders' lifestyles, methods for acquiring food, things like that. You can see on the bottom right here that dinopid, the net casting spider. I don't have time to go into those spiders today, but you can tell they have very large eyes. I highly recommend you look up those guys. You will not be disappointed if you find out what they use those eyes for. They're called net casting spiders for a reason. It's very impressive. So a little bit of homework for you guys. Look those up. Very, very cool. Okay, talked about that. So another thing is the different structures and uses of these eyes. So different spiders use their eyes for different reasons. And consequently, these eyes often have different structures that are present in some spiders and not others. For example, I mentioned that the wolf spiders I was looking at had these reflective structures. Those are not in all spiders. They are called tapetum, and they're actually a crystalline deposit that is uh, reflecting light and reflecting it into the photoreceptors of a spider's eyes. So essentially, it's increasing the low light sensitivity. Simply put, it lets spiders see better in the dark. So that's the dew that I was looking at. So to kind of give you an example of what this looks like, hopefully you can see this. So this is a mama wolf spider. You can see her eyes shining on the left. But what's crazy is you see all those many shines on the right on her back. Those are her babies. That's actually like a backpack of baby spiders. It's like a starry night, like a mirage. It's almost artsy. And she's a very good mother. She's protecting them from the human that is getting way too close to her babies. So she's gonna walk away. But yeah, if you see stuff like that, it's almost like a work of art. It's actually very, very cool. Okay. Uh, moving right along. So you've got all of that, but getting even more specific, different eyes have different functions, even within the same spider. So different pairs of eyes, of spider eyes, have different functions and sensitivities. Spiders have different uh, sets of eyes, which can essentially be broken down for all intents and purposes, this time can be broken down into principal eyes and secondary eyes. They have their own pairs, but we'll go with secondary and principal eyes for today. For example, the wolf spiders have tapetum that are located in one of their pairs of secondary eyes. Many spiders can't actually see very well through their eyes, so they kind of rely on the hairs primarily for sensing their environments. But jumping spiders in particular have really good eyesight, and they use their secondary eyes to detect motion, shadows, lights, depth perception, things of that nature, while they use their front eyes for resolution. Their front eyes are also shaped differently and have what are essentially eye tubes. So spiders aren't actually able to, move their eyes around the way we do. We can look left, right, up, down, move our eyes in all directions without moving our head. Spiders can't do that. But the eye tubes within a spider actually can. And some spiders are transparent, so we can actually see the eye tubes moving around. If you look at that video, you can see the eye tubes of the spider moving around in through their head. They also, of course, turn their head sometimes to see, but you can see that. That is very fascinating to scientists. Okay, so we talked about spiders being hairy, leggy, having a lot of eyes, recovering a lot. But all of these things are not necessarily a bad thing. They're very, very interesting. But let's move on to them being fast. Why are they so fast? I used to wonder this as well. All throughout my life, I've been trying to catch spiders. I always wanted to know. I wanted to know what everything was. I wanted to identify everything. And I'm much better at catching them now. But previously, when I was younger, it was really hard. I was not always really good at it. They were super fast. And I wanted to know, why are they so fast? The spider in this picture is called a flatty spider. And these spiders are considered some of the fastest animals that we have because they can turn around extremely fast. They can turn around about 180 degrees in 1/8 of a second, and they can make 3.5 full revolutions in 1 second. So they have some of the fastest rotation abilities of any land animals, and they're actually being studied by engineers to improve robotic maneuverability. But again, how do they move so fast? So one of the reasons that spiders are able to move this quickly is because of this hydraulic pressure system that I mentioned before. They move hemolymph, or what we're just going to call for now spider blood, through their bodies very quickly and through their legs. And so the more pressure that is exerted on these legs, the faster these spiders go. So that's one of the reasons. Another just practical reason is, again, because of their eyesight. A lot of people often tell me, oh, spiders are really scary because they turn and look at you really fast. That's because they're trying to see you. Like their back eyes are often used for motion detection. So if you approach them from behind, they turn around just so they can see you better. It seems scary to them, but honestly, it's basically the same as if I went suddenly. That's all that is. They're just looking, they just want to see you a little bit better. And then, of course, they move very quickly in order to survive. They need to move very fast to capture their prey. They're trying to catch things that are moving quickly, things that we don't really like mosquitoes and flies and other things that get in our house. They have to move quickly in order to catch those things. So that's one of the reasons you see them moving very quickly. They also move quickly in order to avoid predators because they have other things that are chasing them, whether it be a parasitic wasp that's trying to use them to lay eggs on them and use them to feed their own babies, a bird that just wants to eat them, or a two-legged giant chasing them with a shoe. They got to get out. They got to move. They don't they don't want to die, and they don't even really want others in their personal space. We wonder why they move so fast, but wouldn't you also move fast in this circumstance if someone came behind you? That happened? Yeah, you got the spiders that jump up and I got to get out of here. It's the same kind of feeling. People often say nope, nope, nope when they see a spider. Actually, spiders often feel the same way. That nope feeling is kind of mutual. But they just run away. They don't try to kill us in the process. Another quick side note, if you really want to see a very fast spider and an interesting method of escape, highly recommend looking up wheel spiders. Wheel spiders. They are very, very cool. They actually live in the desert, and they're hilarious because they dig under the sand to hide from wasp. And if they get found by a wasp, they pop up, curl their legs in to kind of be shaped like a wheel, and then just roll downhill as fast as possible. They've been clocked at up to 44 revolutions per second in that way, depending on how steep the hill is. So they're just turning to get away. Those videos are very interesting. Okay, so we've gone through hairy, leggy, too many eyes, they're fast, all of these things. And hopefully we're realizing at this point that these characteristics of spiders, they might be true, but they're not necessarily negative. But what about these last two, mean and deadly? Well, let's just check about the validity of these assumptions. So again, as a child, adults were always telling me that spiders were dangerous. Spiders are mean. Spiders are going to attack you. Don't get anywhere near the spider. It's going to bite you. And so, of course, my impetuous little 6-year-old self decided to conduct my first experiment. And I found a spider on the sidewalk and decided to try to get as close to it as possible and see if it would bite me. Why not use myself as a test subject? And again, once again, I do really appreciate my family, especially my poor, formerly arachnophobic mother, for putting up with me and my various shenanigans, even at the age of 6. So I was waiting for the spider to bite me, and it kept running away. So I would get closer to it, and its little legs would just be flying, trying to flee in a desperate escape. And so, after watching this frantic getaway several times, I remember thinking, all right, I don't know if I believe you. I don't know if I believe all what these adults are telling me. These spiders are so dangerous. What I'm seeing is not matching what I've been told. So where do we even get this narrative from anyway? Where do we get this story that spiders are all mean and deadly? Well, a lot of it comes from news and the media. In the past, most of the news that was related to spiders was negative and sensationalized. And in many cases, it still is today. It's getting better, but it still is today. Some of you might have heard of Joro spiders, these large spiders from Asia that are invading the US. This is an article headline from 2022. This kind of article spreads fear and mayhem. But the only thing that was true about this is that these spiders are quite large. They did end up over here, but they're not really horrifying. They're not falling from the sky, as I was often told. They just ended up here because they got transported over here. And so they did what spiders do. They built large webs and just tried to survive. They weren't trying to harm any humans or do anything negative to us. They just built webs. We as humans do have a habit of walking through their webs and kind of flailing. So we do kind of get caught in their webs, but they're not actually trying to catch us. We also get these negative perceptions a lot from movies. Movies often depict spiders in a frightening and unrealistic manner. Maybe some of you guys remember Arachnophobia, Eight-Legged Freaks, those types of movies. They depict spiders like this, massive spiders attacking police cars, could probably take on a horse. Like, this is not remotely accurate. In fact, this spider is actually based on Habernatus orbis. Habernatus are paradise jumping spiders. They are one of the main spiders that my lab focuses on. And actually, I'm going to show you. Again, giant spider attacking a police car versus what you're actually going to see. Can you guys see this? This little tiny, teeny tiny spider. This is my finger. Can you see this little teeny tiny spider in this vial? This is what this looks like. This is the same genus. They're this small. They are so tiny. Oops, went backwards a little bit. You could probably fit 6 to 8 of them on your thumbnail. They're very, very small. And yet we get these crazy depictions like this. And this sticks in your mind. It really does. Okay. We also get a lot of medical misdiagnoses, unfortunately. So people often go to a doctor and say, hey, I have 2 holes in my arm. I think I got bitten by a brown recluse. And honestly, a lot of doctors will say, okay, yep, looks like it. Let's get you treated. But the fact of the matter is, it's not their job to identify what bit you. They don't know every spider that's around. They don't know their ranges, the spider's ranges, like where they exist in different places. They know their job is to identify the problem, make you feel better, treat you, and show you that all is well. So if you show them a bite and say, this is what bit me, a lot of times they have no idea what actually bit you. They might just roll with it, and that's okay. But part of that results in people saying, oh, all these people are getting bitten by brown recluses. Not necessarily true. I get told all the time by people in this area, oh, but a brown recluse bit me. A doctor confirmed it. I say, did you see the spider? Well, no, but there's 2 holes. It could be something else. Or, well, I saw a brown spider. There are over 50,000 species of spiders, probably most of which are brown. Honestly, there are no documented brown recluse populations in this area. There are no brown recluse populations in the Bay Area that we know of. I'm not saying it's not possible. Sometimes you get a hitchhiker who manages to travel in someone's suitcase over to the Bay Area, but generally it's very unlikely to happen. If you think you got bitten by a brown recluse here, you probably didn't. Someone also recently made a very helpful little song about these guys. This came out recently. It's very catchy, super useful, and it's stuck in my head. So I will be subjecting you guys to this as well. Quick little video about how to identify a brown recluse. Hopefully you guys.
If you got a spider, think it might be a recluse, but there's still a little bit of doubt. Here's a little list that you can put up in your brain that can help you maybe rule it out. Patterns on the bud, it's not loxosceles. Doesn't even have a bud, not loxosceles. Ties are all together, it's not loxosceles. Also, if there's 8 of them, it's not loxosceles. Spines are on the legs, it's not loxosceles. Singing in a web, it's not loxosceles. Shouldn't have to tell you this is not loxosceles. And even if it is, you're alright, as long as you don't squeeze it.
Yeah. Hopefully that was useful. A little bit of fun information about brown recluses. Okay, and lastly, of course, I have to mention black widows because those are the things that are around here. They are all over the Bay Area. And honestly, these things are super shy. They get a really bad rep, but they really don't want to bite you. A study was done in 2013 looking at about 1,900 bites that were reported to a poison control center, 14 of which actually resulted in significant symptoms of any sort, something that would actually really, really affect somebody. There were no deaths. In fact, nobody's died from a black widow bite. No one has died from a recorded black widow bite in several decades. So it's really, really unlikely that they are these, imminent death harbingers that are coming. They're also not waiting to attack you. I actually had to go and collect a whole bunch of black widows for another lab. So I went out and collected maybe 100 of these things in 3 or 4 hours. And honestly, it was kind of sad watching them because they would try really hard to get back in their little crevices. And if I blocked their crevice, they would roll their legs into a little ball, almost like a little marble, and just play dead. They would kind of fall out of their webs and kind of roll a little bit. It was actually really cute and kind of sad. So if they can avoid it, they don't want to bite you. Again, venom is very expensive, and they'd rather use it on something they can actually eat. They'd rather just get away from you if they can. They also don't always inject venom. Like I said, venom is expensive. So if they can keep it to themselves for now, they are unlikely to use it on you. So you actually have to work pretty hard to get bitten by them. It can happen, but you got to work pretty hard. So the bottom line is they aren't mean. They're just doing spider things. And they are deadly, just not to us. They keep mosquitoes, flies, and other insect populations down. If you do get bitten, yeah, go to the doctor, but don't worry about being in imminent danger of death. Okay, so we've looked at all of these characteristics of spiders and figured out which ones are true and which ones are false. And we've looked at the perceptions of spiders based on these different characteristics. And hopefully, if you hated spiders before, maybe your perception of the big bad spider has shifted a little bit at this point. I personally can't get enough of spiders. I am entirely captivated by them. And when I realized most of the information that I was told often had a negative or inaccurate bias, I decided I'm going to study them for myself. These guys are misunderstood, and I want to understand them. So thus began my spider research journey, and it has been incredible. And the rest of this talk is going to talk a little bit more about what I have done with spiders. So I spent weeks studying orb weavers in Puerto Rico as an undergraduate, learning about their web components and how they change their webs based on different humidity levels and weather patterns. I learned they're actually really good indicators of environmental health. These are some of the pictures that I got to take and some of the spiders that I saw. I spent time in the Amazon rainforest, traipsing around through mud in the forest, so I could examine the diversity of spiders in the forest. And let me tell you, I found some pretty large guys out there. I also studied personalities in wolf spiders in Cincinnati, and I learned that yes, spiders do have very simple but distinct personalities. This is the spider that I in particular was studying, the brush-legged wolf spider. Studying in Cincinnati also allowed me to teach my first classes and discover the joy of teaching, as well as helping out other labs and other animals along the way. So I got a lot of experience while I was there, and it really kind of helped my love of research flourish. And so now I'm here at UC Berkeley working on my most intriguing subjects yet, those being jumping spiders, which, by the way, don't look nearly as terrifying as people think they do when they jump. If one is jumping at you, just know that this face is what's actually flying in your direction. So nothing to be afraid of. In addition to that, jumping spiders have some of the coolest leg movements. I already showed you how scientists are studying jumping spider leg movements and the biomechanics of their movements. What I didn't show you, and I will only show you a brief snippet of this video, is that in addition to that behavior, those scientists also created a bloopers reel, which highlights that spiders are not just predators running around. They also can be very clumsy and make a lot of mistakes. So they put these spiders on kind of a post on one side and had another post on another side. And they tried to get the spider to jump from one post to the other. And what they learned is that spiders often miss their mark. They often don't want to jump, and they often crash land. Again, not going to show you a whole bunch of this, but just so you kind of know what this looks like. Supposed to be jumping to, oh, no, you missed it. Wait, no, nope. I don't, it shouldn't be that hard. And we think, but nope, they're really not trying to do this. I promise they're trying to, well, I'm not being very convincing, but they're trying to hit their targets. So anyway, I'll keep moving, but these are also the things that we're very afraid of is that. So they can be clumsy and make a lot of mistakes. They also have exceptional eyesight, probably the best of any spider families, not evidenced by the video I just showed you. And many of them can actually see colors. They're probably also some of the most intelligent spiders that we have, or that we know of. They have all of those extremely sensitive hairs that I mentioned that allow them to detect changes in air currents, approaching prey or predators, or other spiders that they might want to interact with. They're quite fast, but they are not mean or deadly or dangerous at all. And I get the absolute pleasure of studying how all of these attributes influence how jumping spiders communicate. So, like I said, I'm going to be talking about my research and what I'm doing right now. So, I don't know if you guys have seen these guys before. These are peacock spiders. They took the spider world by storm 10, 12 years ago, but these guys are located in Australia, and they kind of do these crazy dances. Tucker mentioned that I say that spiders dance. This is what I mean. I'm not exaggerating. They dance. So jumping spiders have complex ways of communicating and sending signals to each other. And some of these include visual signals, like waving their arms around in combination with different colors and ornaments on their legs or bodies. They also produce vibrations that travel through the ground. We call this substrate-borne sound. We need to understand this for us to better understand spiders and for conservation purposes. We generally don't think of substrate-borne sound because we as humans are always thinking about sound that travels through the air and reaches our ears that way. But a lot of animals use substrate-borne sound to communicate. 97% of insects actually use sound that travels through the ground. And some mammals do as well. Elephants also use substrate-borne sound. So understanding how they communicate and how our actions affect their communication is really important and has long-range implications. So now you must be wondering, okay, you keep saying they make sound. What the heck does that sound like? You're showing us the visuals, but like, let us hear it. So yes, I will absolutely let you hear it. I'm not going to show you a peacock spider sound because those are in Australia, and I want to give you something a little more close to home. So I talked about those Hibernatus, those paradise jumping spiders, the little guy I showed you in the vial, or the one attacking a police car, whatever is your fancy. Those guys are actually all over the Bay Area. You can probably find them in some of your backyards, your nearby parks, things of that nature. And they make some pretty incredible noises. So we have really advanced technology now. We have what's called a laser Doppler vibrometer that allows us to actually hear what they sound like. So here's an example of one species. This is the male. When he's close to a female, we don't want him to touch her, so we'll back him up. Turns into a cat. Not enjoy that. Round two, let's do it again. This time it'll be bad. No. So they can produce all kinds of different sounds, and they have all these different mechanisms for producing these sounds, whether it be drumming the substrate they're on, internal mechanisms in their legs, or clapping different parts of their bodies against each other. They can use all these different ways to produce sound. My lab does a lot with these particular types of spiders. I love these spiders as well, but I actually ended up falling in love with a different spider species that is much larger and actually kept as a pet. So, moving on. So these guys are regal jumping spiders. You may have seen them if you've been looking on social media recently. They're becoming pets and are, like I said, recent social media stars. These gorgeous spiders are found primarily in the US and in the Caribbean. People are starting to keep them as pets and realize that they're actually very highly visual, super curious, large for a jumping spider. So again, showed you the small one. These guys are about an inch. Unlikely to bite, and ridiculously cute with their little heart shapes on their butts and whatnot. So the black and white one that you see in the top right is the male, and the females come in a variety of colors. So all the other ones you see on this are females. So people are beginning to learn and share more information about these guys, and I wanted to contribute to this knowledge gathering. People have a lot of questions, and I want to answer them. So in addition to communication, though, I also personally am very interested in this concept of preference. Do spiders have preferences? I want to know. So, like I said, I'm studying preferences. We as humans have preferences for many different things. The people we interact with, noise levels, music, food, how much time we spend working, different atmospheres, all those kinds of things. And these preferences can change over time and change as we gain experience. Many of us probably have preferences now that we did not have 10 years ago. This is also true of many animals. If you have a pet, you may have noticed that your pets have a favorite toy or a favorite treat or a favorite place to nap. I don't know, but most of us have experienced preference at some point, and this is pretty common in animals as well. In fact, in a lot of animals. Did you guys know that spiders experience preferences? I didn't, but I do now. Spiders actually experience preference too. They have preferences for different colors, ages, temperatures, sounds, size, textures, all of these things. And all these factors can affect their behaviors and interactions with others. So, as a scientist and spider enthusiast, I find this fascinating. And I was curious about how these preferences, in combination with their communication styles, might influence whether or not regal jumping spiders decide to mate or how they choose a partner. So, in order to find these guys, I had to, oh, I actually have a spider that looks almost just like that, which I will show you in a minute. I had to head to Gainesville, Florida, where I worked on a horse farm. And I found a lot of the spiders on this horse farm. So a lot of the spiders would actually make little webs on each individual fence post, which was really interesting. So this was super convenient for me. The spiders were convenient. I had lots of little helpers or impediments, depending on what you want to call the horses and dogs. Sometimes I got a little distracted, but I was able to capture a whole lot of spiders this way. And this kind of shows you what their little nest looked like. And just to kind of show you what it looks like when I caught one, this is a very small one, but it's a little juvenile uh, regal jumping spider. So that's what she looks like in a vial. So I wanted to see again if these guys have mating preferences. So I brought them back to the lab. I caught quite a few of them. I raised them until they reached adulthood or maturity, and then I would randomly pair them together in an arena. I wanted to record their courtship. So do they do they wave their legs around? Do they drum? Do they tap? What do they do? I want to look at these visual and vibratory signals. I also wanted to analyze other important factors for mating success. Does the size of the spider matter? What about the length of their legs? What about how much courtship they're actually doing, their effort they're putting in? What about how old they are? How much aggression a female shows? So I wanted to look at all of these things. So here's kind of a cartoon depiction of what these arenas look like. Put the spiders in, put some lights over them and a camera, and just say, go for it, I'll watch. But to give you a more realistic depiction, kind of looks like this. So the male is on the left. I want us to just appreciate how much effort he's putting in, saying, notice me, I'm right here. So this is one of my trials. But one thing I also want you to notice is that he's actually not producing vibrations that are specifically associated with mating. The sound that you're hearing is just him walking along that substrate. He's not doing anything extra that is particular to mating with this female. Oh, moving on. Also, just to give you guys a little bit of a view, hopefully you can kind of see her. This is how much bigger these spiders are. I'm trying to put this back up so you can see. You can see this spider is way bigger than the little one I showed you previously. This is one of my regal jumping spiders. She's very cute and chilling in this container, but she is probably 50 to 100 times bigger than the spider I showed you previously. Oh, she's moving around. She says hi. But yes, so those are the kind of spiders you see in those trials that I showed you. So, okay, I've got all these factors that I want to look at: age, mass, size, length, but I also need a baseline. What am I expecting to see? So I did some research, and I found that some other people have run trials like this. And so far, they've seen that generally jumping spiders mate around 30 to 60% of the time the first time. First time they mate around 30 to 60% of the time. Otherwise, they reject the male or eat him or something of that nature. So that's what I'm expecting. All right, got my baseline. That's what I'm going to see. I'm ready. Except for no, they did none of that. They made it every single time. It was, they kind of threw a wrench in my plans there, because there's no reason to measure all these things if none of them matter. If they made every time, then they're not paying attention to any of that. They made it 96% of the time. So, okay, great. Well, what do I do now? Kind of changes what I was planning to do. But then I remembered, oh, wait, what if they change their mating preferences based on experience? So I decided I've already mated them. They've gotten some experience. What if I mate them again? So I did. I mated them again, and this time they only mated 45% of the time. All right, now we're in business. Now it's interesting. So now I want to look at all of these factors. So I've looked at a couple of the factors so far. I've looked at the age and the mass of the spiders. That doesn't seem to matter. What I'm currently doing is slowly going through a ton of videos of spiders mating and courting, because each of these videos was 15 minutes, and I have hundreds of them. So I'm slowly going through and measuring how many times the male lunged forward, how much time he spent with his arms outstretched, how much time the female spent looking at him, all of those things to determine if the male's individual courtship effort mattered in whether the second mating occurred or not. So that's what I'm currently doing. Haven't finished it yet, but that I'm excited for the results of that. What has been really interesting is something that I realized in the last couple of years is that these spiders, again, have a lack of preference in the beginning. And I was wondering if this lack of preference can affect their species boundaries, especially when combined with our actions as humans. So as I told you, I found these guys, these regal jumping spiders on the left. I found them on a horse farm, which is primarily made up of short, fences. But these guys are normally found on shrubs and palm fronds. I guess jumping spiders just really like fences. Surprisingly, I actually found another jumping spider on these fences as well, a closely related one. These are canopy jumping spiders here on the right. They're supposed to be high up in the trees. Why are they down here on these short little fences? And so what I found out, at least what it seems to me, is that because we as humans built these short trees that are neatly spaced apart, canopy jumping spiders came down out of the trees into these short little trees. Our regal jumping spiders came up out of the palm fronds onto the short trees once again. And now you've got these species that don't necessarily always interacting with each other. Okay, that's interesting in itself, but also my initial spiders have a lack of mate preference. What if that also applies to other species? What if they run into other species? What if they mate with them? What if they hybridize or mate with another species? And it turns out they do. I've been running a bunch of trials with both of these species together, mating with each other, and they are willing to mate. So I'm ending up with all of these hybrid babies running around that have a combination of their parental characteristics. And this is even more interesting because regal jumping spiders, like I said, they don't vibrate when they're courting. These other guys do. So you have these babies running around that have a combination of their parents' characteristics. They look kind of like the regals and kind of like the canopies, and they vibrate, but not in a way that either of their parents do. So is this maintainable? Do they mate with each other? Would they mate back with their parents? What's going on? And are we as humans affecting this? Are we playing a role in this happening? Are we gaining a new species or losing the distinction between two? I don't know. That's what I'm studying right now, and I'm super intrigued. Okay, so what have I learned so far from my research? Well, regal jumping spiders gain preferences with experience, and these experiences affect their decisions. So this helps us understand the links between their brain and their behavior. Also, these decisions influence what characteristics are passed down to future generations. We know that we get many characteristics and even preferences from our parents. The same is true of animals. So these decisions can affect how animals persist, adapt, and evolve. So all of this, again, very, very interesting. Why does all of this matter? Well, this could impact species boundaries. So again, these spiders, regal jumping spiders and canopy jumping spiders, are mating together and producing hybrids. Are we losing a species? Are we losing two different species and gaining one? What's going on? This is also important for our ecosystems because spiders are important predators and also prey in our ecosystems. And they keep harmful insect populations in check. So understanding how they communicate can tell us a lot about their habits and what factors might affect their long-term preservation. They're also excellent models for other animal communication because a lot of animals use substrate-borne sound. They're not always readily accessible. It's a lot harder to go, study an elephant, but you can get spiders everywhere. And understanding it better helps us inform our conservation practices. And in general, having greater accurate knowledge about spiders empowers us to alleviate some of the widespread fear that is often just a product of misinformation. Okay, so let's just recap. We've looked at a whole bunch of descriptions of spiders and analyzed their validity as well as the functionality of some of these attributes. We've established that they're hairy, they're leggy, they've got a lot of eyes, they're fast, they are not mean and deadly. But these aren't necessarily negative. Them being very hairy is not necessarily a negative aspect, and sometimes they just look like little sheep. If anything, like I said, they're not mean and deadly. They can be quite shy and cute. They're also very curious. They're not really interested in attacking us. In addition to these words that we've already looked at, I also want to leave you with some words maybe you'd like to add to your vocabulary regarding spiders or your descriptions of spiders if you don't use these already. These are some ways that I describe spiders. Spiders are diverse. They come in many colors and types. They're beneficial. They keep insect populations down and help us regulate the environment. They are absolutely beautiful. They are charismatic. I hope you all go home and watch jumping spider videos. They're inspiring. They teach us a whole lot. And generally, they're just kind of awesome. So I want to leave you lastly with this quote that hopefully kind of summarizes what we talked about today in a nutshell. Spiders are misunderstood little creatures, and they really don't ask a lot. If anything, they're full of helping hands or legs, so why not give them a shot? Thank you so much for coming to this talk. I really enjoyed spending this time with you. Please let me know if you have any other questions. Feel free to reach out, and yeah, I'll be here for questions. Thank you so much.
Wow, Trinity, this is great. I have a feeling Leah, who is our master and perhaps mistress of ceremonies, wants to weigh in here. But I've had the privilege of listening to you before, and you've just, your game is even better than earlier. Do you care to answer some of the questions you see there in the chat?
Oh, I have not looked. Let me see. Okay. Where did
If you want, I could read the questions out.
Sure, if you'd like to.
Sure. Okay, so one of the questions is, do spiders see the same spectrum of visible colors that humans can see?
That's an excellent question. So no, it depends on the spider for sure. Jumping spiders definitely have the best vision that we know of, and they can see more of the colors that we can see. Their vision's closer to kind of like cat vision. We didn't think they could see red before, but there's some research that's come out recently that seems that they can also see red. Some of them can see red. They can see green. They can see some other colors. They can't necessarily see all the blues and some of the other things that we can see, but they can see different ones. They can also see some like ultraviolet light and other things that we can't see. A lot of spiders, though, can't really see any colors at all. So it depends.
Thank you. Another question, do all spiders have hairy legs? Some seem to have skinny, bare legs. Do those spiders have sensory hairs?
They do. So a lot of spiders do seem to have really, really skinny legs, but if you zoom in really closely, they actually have hairs as well. They're just not as readily visible, but they do all have those sensory hairs on their legs.
Cool. Is it true that the bite of very few Bay Area spider species can even break human skin?
That's a good question. I don't know if that's true. I would say, quite a few spiders can break your skin, but you're not really going to have a reaction from them. I got bitten by a spider for the very first time recently, and it was super cute, did nothing. I felt bad for a little baby. It was honestly a really funny experience. But yeah, I would say that quite a few spiders can bite you if they really tried. They're just not likely to try. They'd rather just run away.
Okay, another question is, I heard that house spiders cannot survive outside. However, in SF, the weather is so mild. Can house spiders survive outside? If not, I will continue to capture house spider and throw them in the basement to live.
So wholesome. I love that. So that's a great question. It depends on what kind of spider you're talking about. So there are spiders that we call house spiders, and there are quite a few spiders that probably were born in your house. They've been there the whole time. They'll die in your house. They'll have babies, have full generations in your house. And yes, some of them are actually adapted to live in your house. So some of the ones you see, if you can just leave it alone, especially if it's in a little web or in a corner or something, just leave it. It'll live, it'll run away eventually. You'll probably never see it again. If you do, it probably just picked a new corner and is keeping your fly populations and other insects at bay. If you run into some of the other spiders that we sometimes see, like wolf spiders or other spiders that just happen to be in your house, sometimes those guys are just passing through and you can just throw those outside because they don't actually mean to be in your house. It's just kind of a pathway for them to get to the next destination. So if you know what it is and you know it's a spider that didn't necessarily mean to be there or probably won't be there for very long, you can just toss those out.
This is slightly related. It says, will spiders float down, e.g. survive, if poured from the second floor?
Poured from the second floor. Try to
I think maybe somebody's thinking if they throw it out the window, will it make it?
I was imagining like a spider in a bucket of water and it just like
Oh, that could be.
yeah, it depends on what you mean by that. If you mean like throwing it from the second floor, honestly, probably because they're pretty light. They'll probably just catch the wind and float down to the bottom eventually. But I mean, if you can take them downstairs, that would be great. We prefer you don't throw spiders out of second story windows, but also you're more likely to have them land on other people, in which case the people down below you will not appreciate that. But pouring them, I've never thought of this question. This is a very complex question. I don't know. Honestly, I feel like they'd survive. They'd probably be fine as long as I don't think they'd hit anything super hard. Um, Probably, but generally I would not suggest pouring spiders with water out of the second story. I'm not sure how to answer that question.
That's okay. Okay, do we know how they regrow limbs? Application for humans to regrow limbs?
Yeah, that was actually something that so I think that somebody is studying that. I think people are actually studying that in quite a few different types of animals. I was actually going to look that up because that's also something that's interested me recently is how we're applying these kinds of things to humans and our survival because we're using those kinds of things like we're using the properties of venom to actually develop things like addiction-free painkillers and things like that. And looking at how we can use these different applications for humans. I don't actually know exactly how they regrow the limbs specifically. I mean, it's look, I kind of do, but it's a very long process. It would take me a long time to describe exactly how spiders molting works regarding how they have two layers and how the inner layer breaks down and separates from the outer layer and how they regrow the new layer and all. That's one of those things where I would probably suggest looking up something like that, just because if you want the nitty gritty of it, it'd probably be better to actually read an article on it. And I'm happy to send that out to Leah if you'd like that kind of information. But actually, exactly describing in depth how they regrow the legs is pretty complicated.
Understood. Somebody says preference equals personality.
They can be different. They're definitely different things. Personality is more of animal personality really involves looking at repeated behaviors in individuals over time. So if you have one spider, for example, when I looked at wolf spiders, I would put the same spiders that grew up the same way, had all the same food, etc., in the same type of trial, and the spiders would react differently every single time. Spider A, if I put him in like an open field, spider A would always cower and just be really scared. spider B would immediately start exploring, looking around. What's this? What's going on? This is new. So that's what we mean when we say personalities. They react differently. Having a preference for something, not necessarily the same definition of a personality. Also, preference can be applied widely. So maybe certain types of spiders have preferences for one thing versus the individual. They're a little different, but they can be associated.
Let's see. I think there's a couple more. One person asked how big the terrariums are that the spiders live in.
You mean the ones behind me?
I'm not sure. Leonie typed that one. Maybe well, maybe she could, or they could chime in. And then there's the other question was, somebody asked, when you were in Gainesville, did you connect with Dandroid's aperture science?
I didn't.
And there's a link here in the chat if you want to look. I guess it says, I love his photos of jumping spiders.
I do not think I connected with, let's see. No, I don't think I connected with that person. I connected with a lot of jumping spider or spider scientists in Gainesville. I always go out. We always go out as a horde and go collect spiders for each other. It's like this big spider scientist little mini convention that happens when I go. But I don't think I've connected with that person. Thank you for the info. I'll definitely look that up. And regarding the terrariums, assuming we're talking about the terrariums behind me, generally it depends on the spider, especially tarantulas when they're tiny. When they're young, I mean, they can be really small. So I just upgrade them periodically as they get bigger. I would say most of them are probably in 8 to 10 gallons or so or more, depending on what kind of spider they are. And they vary based on the spider's behaviors. So some spiders are spiders that dig. And so some of the terrariums have less width, but they're really, really tall. And it's just full of dirt because the spider just goes down and just digs a real big tunnel. And I never see it for months. And I just hope it's alive. So basically every terrarium is very different depending on what's in it.
Cool. Okay, I'm going to have you answer one more question if you don't mind.
Okay.
It's what's a good starter pet spider? Or is it best to keep them wild and free to observe rather than keeping them as pets?
I love this question. I do. So I would say that generally there's not really wrong to get a pet spider. If you want to go out and catch a jumping spider or something like that and you want to observe it, that is totally fine. They also, something I didn't talk about that I love, that I'm also studying, that I'm not going to talk about a lot right now, but jumping spiders have tons and tons of babies. The girl that I showed you here, this one you can probably see, she is quite chunky. That's because she's pregnant and going to probably lay 200 or so eggs very soon. And she will lay 6 different egg sacs. And so she'll probably give me a solid 800 babies. And I have so many grand spiders, I can't even keep track of all of them. So taking one spider out of the wild is really not going to hurt anything. I would say if you're going to take it, make sure you give it a good home, lots of food, nice, good space. And if you decide that it's too much for you, you don't want it, just put it back. They know how to live. They'll be fine. Regarding a good starter pet, 800 babies, not at all at once for this guy, but some spiders do. But starter pet spider, I would definitely say jumping spiders are really good for that, especially the bigger ones. The small ones, you're probably going to lose them, honestly. They're very tiny. They're really good escapees. So big chunky ones are good ones. But they don't live super long. I will say that. So if you get really attached to your new baby, these are long-lived jumping spiders, and they're like 2.5 years. The little one I showed you before is like a year tops. Tarantulas, on the other hand, that's a commitment. So if you want something that's going to live a long time and you get to grow up with and all that, that's wonderful. But know that you're committed now. Some of these guys, I'm in for 30 years. Like, this is what's happening. This is not a small endeavor. Many tarantulas, especially the females, will live for 30 or more years. I think the oldest spider that we knew of was like 42 when it died. So just make sure you do enough research to know what you're getting into, how much space it needs, what it needs to eat, all those things, and know if you've got a new lifelong partner.
Wow.
Wonderful. Thank you. I just want to add that there's lots of thank yous and awesome
Aw.
and great talk in the comments.
Thank you guys. I appreciate it.
And I'm going to let Tucker close it out.
I'm just going to say thank you to you, Leah, for hosting this great event, and to San Francisco Public Library. And of course, maybe we'll give American Sign Language inaudible applause for our great Trinity Walls, our arachnologist, our great science envoy. Thank you, Trinity. Thank you, Leah.
Thank you.
Thank you.
All right. Good evening, one and
Good
all.
evening.
Mhm.